the work that we've performed, we've tested a range of disinfectants against a whole plethora of bacteria. Now, you can imagine how many bacteria are known to humans. I mean, they run into the hundreds of thousands, potentially millions of different types of bacteria that are out there. We've tested against all the kind of the ones that generally raise concerns. So these could be things like MRSA, they could be E. coli, they could be spores that you find, so C. difficile spores, and the results always the same. It's familiar. You know, we get substantial kill. And a lot of biocides and disinfectants, they're measured against very unified and standard tests. And these are called EN tests, and they are European-wide. And in fact, they have similar tests in the States and similar tests in other parts of the world. And ECAS operates no differently than other accredited or plausible disinfectants. So they kill a whole range of organisms. And one of the questions I get a lot when I'm working with partners in particular is, well, does it kill X and does it kill Y? In reality, no biocide has been tested against all bacteria because that just doesn't make sense. From a scientific perspective, what we usually do is we take what we call gold standards, and those gold standards are usually types of organisms that are really, really, really difficult to reduce or kill. And we know that through the work that's been done in the past. So many organisms that are very difficult to kill include things like spores. So a lot of the gold standard tests that are undertaken are against a range of spore-like organisms, which are known to be really, really resilient to chemical attack. Or disinfectant attack, principally because they're sort of round balls with very hard walls, so it makes them very difficult to be penetrated by the disinfectant that you're interested in. And certainly in the work that we've done, and again this is out in the scientific literature, we've shown that electrochemically activated solutions provide a substantial log reduction in terms of kill of such organisms. In some instances better than perhaps products that the general public would be more familiar with, so things like bleach. And the nature of the biocide that we're dealing with, electrochemically activated solutions, all of these very excited products that are in this soup, all really, really keen and eager to react with something, means that one advantage of using electrochemically activated solutions is the speed of kill. So we've tested a whole range of organisms with very similar results, but one remarkable thing that emerges from this is the speed of kill. So that is the difference really between ECAS type disinfectants and more conventional disinfectants like alcohol, Virkon, which is a disinfectant we use in the laboratory, or indeed household bleach, is that the speed of reaction or the speed of kill is really, really fast. How fast? Well, we've done some tests on that, and these are not sort of conventional tests, so we don't usually do kinetic testing of microbials or antimicrobials, because that's not a kind of a standard way of assessing disinfectants, but certainly in the techniques that we've used, we've shown and demonstrated, and again this is out in the scientific literature, that the speed of kill arises within the first 2 seconds. So that's within 2 seconds of being in contact with a bacteria on a surface or in suspension, you get some mode of action. And that represents significant advantages in areas where there is a requirement of time, where you don't have the time to leave something for 10 seconds or 20 seconds or 30 seconds, or you need very rapid disinfection, then electrochemically activated solutions provide, I believe, a good alternative.